Good morning, everyone. So this is the first chapter of PLS, Programming Language Structure. The first chapter, we will talk about different types of design and evaluation criteria of a programming language. But to answer the old and the first question is why programming language? Why we learn different programming languages? The first reason of learning programming language is to communicate with the computer hardware. Computer hardware means that we have the memory, that is our hard disk, we have RAM, we have our processor, that is CPU, central processing unit, and so on. So first, to communicate with this hardwares, we need a way to communicate, and that's where the programming language comes in. So to understand how the hardware structure works, you have already started this in your architecture course, but this is just a short idea. This is a von Neumann architecture. As you can see here, we have three main components. We have the memory where we store the informations, whether it's a data or it's a program. Okay, so it can be a software that can be stored in the memory, so it stores both instructions and data. Then we have this central processing unit where it's divided into two parts. One is algorithmic unit, ALU, another is control unit, CU. Okay, what this does, ALU, it does the calculation part. That means every time you do any simple operations, okay, all the calculations are done by this ALU, this logic unit. And this control unit, it actually controls, okay, so this is the first data, this is the second data, so it controls the flow of informations. Okay, that you will go first, you will go second, and whenever ALU needs some information, control unit feeds the information. And the third part is this wares, or we can call it the interfaces, that actually make sure the informations gets passed between the memory, control unit, and arithmetic. So it's called also another name called bus. Okay, so like we can have different buses for different types of tasks. So this is the overall idea. Whenever you everything is stored into the memory, whenever you turn on your computer, the computer can be a desktop computer, it can be a laptop, it can be a mobile computer, everything is almost a computer. Okay, so whenever you turn on the computer, what happens is that this informations are fetched from the memory. Okay, they comes to the control unit then sends them to the ALU where it does the calculation. Okay, and finally, using the input output devices, you can either send input, you can write get output using monitor, and so on. Okay, so you have the idea about how this whole process work. Now, there are different architecture have been proposed over time, that how to make sure this whole operation of storing information into the memory, getting information from the memory, and also at the same time processing the informations, okay, to get an output, how to best do this whole operations. And there are different architecture are proposed, but this is the current one that we use in almost all the computers. Okay, this is the, you can say this is the most efficient one. There are some other famous architectures as well. For example, you have data flow machines, okay, where you have actors, instructions, and tokens. So how does the token work? Think like this: you went to a bank, and if you want to get a service, first thing you need to do is get a token, the serial number 31, 32, 33, 37. So it doesn't matter what you want to do, okay, you need to have a serial number. So every instruction, okay, that comes, it wait for the serial number, and it gets the serial number, just like you go to the bank and you wait in the line, and whenever your serial comes, you get the service. Okay, now obviously the is exactly not the same, because in our computer we have some other different challenges. For example, interrupt. Then you have studied about the IO devices as well. So but the basic idea is same. And then we have the quantum computers. To understand the quantum computers better, I will show you a video from the YouTube, and where they will explain the quantum computer into different levels. Okay, so I'm sure that that will actually help you to understand better than the theoretical discussion. But after that, after watching the video, okay, tomorrow's in the next class, if you have still have any confusion, okay, you can let me know. So why quantum computer? Because this is the latest computer architecture that has been proposed. Okay, and it's one of the best, and it has been proven that it has mathematically and theoretically also as well, that is the fastest possible architecture. That means informations that you previously have taken only like 1 minute now might take 1 microsecond and more less than that. Okay, you can compare in terms of hour as well. So this is the normal layered view of the computer system. So it doesn't matter which machine you work on. At the bare machine, this is the bare machine where all the hardwares and the logical units are. So you have done the DLD course, that is your FEDS course. Okay, in those courses, the idea was to introduce you with this different circuitry of the computer system. That where, okay, so if I say here that we need three circuits and interrupt devices, so you'll have to have the idea that how this interrupt devices or the logical designs work. But luckily we don't need those here, it just to give you the idea. So this is the layered view of a computer, and as you can see at the core level we have the bare machine, that is our hardware. Then we have an interpreter, that is macro instruction interpreter. Okay, so normally whenever you communicate with the computer, we know that computer only understands 0 and 1. Okay, computer only understands zeros and ones. So the problem is, if you want to communicate with the computer, you either have to talk within 0 and ones. Now as a human, it actually very difficult for us to speak in zeros and ones. Okay, so what we do, okay, instead of speaking in zeros and ones, okay, we write programs in C, we Fortran, C++, Lisp. So all these are different programming languages. Okay, assembly, Ada, and then we have basic operating system command. So we use these different programming languages to write programs that will be able to communicate with the computer. So the main purpose of the program, as we have said in the last slide, is to communicate with the computer. So we are trying to communicate with the computer, and we don't try to understand, or we don't try to remember zeros and ones. Okay, so we take help of this programming languages, C, C++, okay, Ada, Lisp. Now the advantage of using this programming language is that these are easy to remember. If you want to, for example, take an input, okay, you just use this scan. If you want to print something, you use printf. Now everyone actually familiar with these words. Yeah, print is an English word, so it's easy to remember. Okay, if you want to write a loop, okay, you use a for, then you use I equals to 0. So these syntaxes, okay, these are easy to remember, but corresponding machine code 0000001, these are actually very difficult to remember. Okay, so we'll talk about this in the second chapter, but for now we know that we can't communicate with we don't communicate with machine interface of a computer. We use C and C++ and other languages. Now the problem of using other languages is that computer don't understand those language. So what we have to do, we have to use a compiler. Okay, so you see, for every programming languages we have a different compilers. What the compiler does, okay, it translates the code from printf to 0001. Okay, that means from each line of code gets transferred to the machine code. Then there is our operating system. Okay, so what happens is that you have done, all of you have done the operating system course, and you know that operating system actually is itself a software, okay, which actually a system software. So what it does, it actually acts as the intermediary between the all other programs and the hardwares. So what the operating system does, okay, it takes the instruction, it allocate the resources, okay, and it takes the instruction, everything, and it pass it to the hardware, make sure the instruction gets executed and gives you the output. So all these are actually done by the operating system. So this is where the operating system is, and then we have also the macro instruction interpreter. This is another level of interpreter that we need for the executing the hardware, and then that's it. So this is our final layered view. So any programming languages, they are not only have to be C, C++, it can be any programming languages. So any language that you use, they are in the outside layer. Then you have the operating system. Operating system takes the translated language from by compiler, okay, and then it pass it to the macro instruction interpreter. Sometimes some instruction need to be further uh, compiled, and sometimes some instruction can be executed directly. It depends on how the language is. Okay, for example, if you look at the assembly language, we know that assembly is very close to the machine language. So in that case we might not need the macro instruction interpreter. So finally, this is how the whole execution continues. Now, why we again studied this course, I have already talked about this in the last class. Let me tell you one more time. So it actually helps you to understand and communicate with the computers more efficiently. So you know that how to, if someone asks you that, okay, I like C++, so there's a new programming language that is also same as C++. Okay, so how can you actually be sure? So you can say, okay, sir, I can be sure by, like, I know that in C++ we have object oriented programming, so I can check that whether that programming is object oriented. Okay, that's good. Anything else? Anything else? No, it's not, because if you just have the normal idea, you only know that C++ is good for object oriented programming. Okay, and some other basic features. So you can only do you can only check for those. Okay, but after studying this course, we learn some new parameters for which we can actually do the comparison. We have improved background for choosing an appropriate programming language. So after that, you will actually know that how we can choose a language for a certain area of application. Okay, so if you want to go for web development, should you go for Java, C, or Python? Okay, so for now, we should go for Python. How I know? Because I know that how this evaluation criteria work, and you will too. Then we have increased ability to learn new languages. So in the chapter 2, when we will see the overall tree of how languages evolved over time, okay, we'll understand that, okay, that's why we learn C programming, that's why we actually learn C++ or Java. Okay, and one more question that will be answered this, sir, why not just directly learn Python? You will see that directly learning Python is good, but if you learn Python before after learning C++, Java, that is much better. Okay, so you will answer those questions. Okay, because only language features matter. We know if you learn one language well, I know you have heard it before. Okay, but if you learn one language very well, it actually becomes easier to learn other languages. Okay, but what happens if you learn a small amount of code for every language just to practice, and you don't practice enough, then it becomes like a hodgepodge. Okay, like, okay, so why I'm learning so many languages, I don't know any one very well. Okay, but what happens once someone learn one language properly, to them the rest becomes very easy. Okay, because at the end it's just the features that matters. And then better understanding of significance of application, that how you can find out the program bugs, how you can evaluate the performance. Okay, and obviously overall advancement of computing. The more you learn, and the more you will know how to make things better. So normally, whenever we are learning or designing a new programming languages, okay, it actually depends on the domain. Okay, so there are different domains where we actually use for computer application. For example, there are scientific domains. Okay, where we have one kind of programs are needed to handle one kind of calculations and computations. Okay, then we have the business application where the computation is not important, the interface and automation is important, so that the system can automatically do this some operations. Okay, then we have the artificial intelligence. Okay, where you want to design different models which in future will do some other operations. Then we have system programming. Okay, because it need efficiency. And for example, even to this day, many programming languages, okay, they use actually C. Sorry, many operating system they use C. And you'll see that if you work in a company that works with SIM card, okay, that is your mobile SIM. Okay, or it works with uh, other operating systems, they will ask you for either code in C, or sometimes they might ask you for C++, but they will not go for other programming languages, because even though Java, Python, okay, Ruby on Rails, those programming languages are better. Okay, but the problem is they're not efficient. Okay, in terms of efficiency, C is still one of the lightweight and fast. Okay, now when I say lightweight, what do I mean? Okay, so whenever you write a program, for example, a program to uh, add two numbers. Okay, let's assume you're trying to add two numbers. So you'll write the same program in C, you'll write the same program in Java, and you'll see between these two, okay, C program will be less in size or fast to be executed. So that's what we means in lightweight. So and it's so in short, instead of explaining all this, we say that C is more efficient for operating system or system programming. Then we have web software that we already, I think you're familiar with, PHP. Then we have HTML. Okay, so these are some of the programming languages that we use web software. So first thing we need to understand is that which domain we are working on, because depending on the domain you might either have to learn Fortran or languages like Fortran, COBOL or languages like COBOL, Lisp or languages like Lisp, C, or PHP, HTML, and so on. Now what happens that currently the new programming languages, for example Python, what Python can do, it can work with the scientific applications. Okay, it can work with artificial intelligence, it can work with business application, it can work with web software as well. So currently some of the programming languages, they have been developed in a way so that it can address, okay, all the criteria, but it also is a very complex process, as you can understand, because previously we only had one language to address one type of application, but right now, okay, if Python addresses all this domain, that means it has to be complicated as well. But fortunately Python is not, and that's why it's so popular, because there are other languages as well that does the same, okay, but the complexity and the overall availability is not same as Python. Python has a huge amount of developers, number one, and number two, there's a lot of libraries, okay, that are available, which are actually very easy to download and implement. So we'll go to that later, but for now remember there are different domains of languages, and depending on these domains, the programs actually differ. So if you're working in one domain, you need to learn that domain specific programming languages. So if you're into web development, you need to learn PHP, HTML, JS, that is JavaScript, and so on. Now, so finally, the criteria. So how we can judge a programming languages. So judging a programming languages have different evaluation criteria. Okay, so there are total 7 criteria. I will first tell the criteria one by one, then I will explain. First one is readability. Programs has to be easily readable. It has to be easily writable. So whenever you're writing the code, it has to be reliable. Okay, your program can actually have uh, uh, error handling. Then we also have this exception handling, and the cost has to be less. And then we have three others. Let me go there. Mm, yes, it has to be portable, it has to be general, so that everyone, it can be used in multiple domains, and it has to be well defined so that you can easily understand which part is for which purpose. Okay, so these are the 7 evaluation criteria of a programming languages. One more time, we have readability, easy to read; writability, easy to write; reliability, it can handle different types of uh, exceptions and errors. Then we have cost, so it will be easy, the cost will be less to develop the code. We have the portability, the code can be run on multiple platform. We have the generality, that it can be used in multiple wide range of applications, and has to be well defined. So one example that I can give you, just think about Android development. Okay, uh, so what happens is that if you're working with app development, now you know that there are different types of devices. Okay, like there are different mobile phones, there are different versions of the mobile phones. So now a question I get from everybody, okay, that's, sir, if I want to develop apps for mobile, okay, which language should I learn? Now you see there are a lot of new languages that are coming on. For example, previously people used to use only Java, because Java is a cross platform programming language. That means a program in Java can be run in different platforms. That is, Java's code is portable. So those of you who have done the Java course, so you already know it. If you haven't, so just know this, that Java is a programming language that can, a same program without any change, can be run in different type of machine, which is not possible for other languages. Okay, so same happen now. There's a new there is Flutter. Okay, so the main point here is that whenever you are trying to develop Android applications, okay, that's, sir, I want to develop an app, which language should I learn? You should first see that before watching any other random resources, you should first ask yourself, so if I learn this programming language, okay, let's assume the programming language 1, I have to develop separate program for Android devices, I have to develop separate program for iOS devices. Okay, and if I learn this programming language, for example programming language 2, if I develop one program, okay, then my program will run in both platform. So if you see that your program is portable, then you will easily understand that then I should learn this one. So this is one criteria. Okay, then there can be another purpose that okay, so the language too, even though if you write one code it will be run in both platforms. Okay, there can be a problem like this, that the problem is the language 2 is very difficult to learn. Okay, or it takes long amount of time to develop a code in language 2, so the cost is high. In that case you will think okay, so let's just develop with language 1 first. So these are different things that you have to actually keep track in your mind. It's just think about like this: you went to uh, invest somewhere. Okay, so what doesn't matter what you do, okay, there are some advantages that you will get, there are some disadvantages you will get. So whenever designing a new programming languages, they try to increase the advantages and decrease the disadvantages. So back to here. So these are our 7 criterias for a programming language. Now, the first criteria, readability, you can understand that it is easy which programs can be read and understood. So to compare the readability criteria, there's one simple example. Just think about the machine code. In the machine code, let me show you a sample. So in the machine code, if you wanted to write like for example C, okay, I think C is printf. In the C, let's printf hello. This is one and in the machine code we have 000101110. Yeah, so this is the print, and the hello, I don't know how what the hello spells like in machine code, but this is the print. Okay, so what happens that if I ask you that memorize this, instead of writing print hello or print f my name, mm, Sakib, you will have to write this exact 000101110001. So you see how difficult it is to memorize this pattern. Okay, now this is just one simple example. Whenever you write a code, there are 1,000 patterns like this. For scanf, there's a pattern. Whenever you're trying to take an input using scanf and save it to a variable, there is another pattern. Whenever you are trying to save one variable into another variable, there is another type of pattern. So if I ask you that between these two code, okay, which one is more readable, you will obviously say, sir, this one is more readable for us. Printf hello, printf sakib, it easily makes sense what you're trying to do, but this actually doesn't make any sense. So we can reach to the conclusion that this program is more readable. Next one is writable. So again, the same thing, right? Between these two programming languages, obviously this one is more writable. Okay, now the next question comes, which one is more reliable? In that case, we actually have to think, because reliability doesn't depend on us. Okay, reliability means that whenever you run the program, okay, computer it depends on the computer specifications and the performance of the reliability. So in, you know that in C programming or C++, there is no exception handling. Okay, so in C++ you can use the exception handling. The features are there. Okay, but we we use the exception handling in Java mostly. So if I ask you the compare readability, reliability between C programming language and Java, you will say, sir, Java is more reliable because it has the features of exception handling, where we can write the code that if there's some error occurs or this type of error occur, exception occurs, you do this type of task. So what happens in a C program, if there's an error, the program crashes. Okay, but in Java, if there's an error, the program shows, okay, this is the error, please try again. So for example, if you're dividing two numbers, this is the common example that you'll find whenever you search for exception handling. This is the first thing you will get. Okay, so whenever you search for exception handling, you will see that the first example is that if I want to you write a program that can divide two numbers. Okay, your program is very simple, it can divide two numbers. So in C program, if you insert 0, so your program divides two number, a divided by b, and then you divide by 0. So your program is a divided by b. So you have taken input from the user and then you are trying to divide by 0. In C, your program will instantly crash. But in Java, if you use exception handling, it will show the user that you cannot enter 0, please try again. So then again you will try another input and then you will get the result. So this is what we call user friendly error. Okay, so user can understand what is wrong, and then he can actually give another input. So this is reliability. And now we'll talk about the cost later. So let's today, before finishing the class, let's just read and see two examples of readability. So as you can understand that maintenance was recognized as a major part of a software lifecycle. Whenever you develop a software that is a large scale software, think about a Facebook. Okay, so Facebook is nothing but a software, right? Okay, and what is the number of code in Facebook? Okay, so let me give you an easier example. So you see, sometimes there are some mini games that you can play in Facebook. Okay, some of the codes are actually from 50,000 lines to 70,000 lines. Okay, just a simple game that you play needs 50,000 lines to 70,000 lines. Now if you search, you'll easily get that Facebook code contains more than that, actually multiple than that. Okay, now the question is, after developing a software, it's not done, it has to be maintained regularly. So maintenance is a major part of the software development life cycle. If you have done the software engineering course, so you know how important it is. Okay, if not, let me tell you in short. So in SDLC, software development life cycle, there are 7 phases. Okay, so it starts from designing what the software need, and then go to the feasibility analysis, that whether you can make the software properly or not. Okay, then you actually develop the software, and you test the software. Okay, and then you have to maintain the software, and so on. Now, to do the maintenance, especially in a large code, you need to have the code in a form that is easily readable. Okay, so that you can read the code. If there is any mistake, you know where to change or what's the problem. Okay, so what are the criteria for readability? So obviously this is a one major domain. So first of all, your program has to be simple, overall simplicity. So you have to use simple core features. You have to use as much less feature multiplicity possible. Okay, so what does this feature multiplicity means? That, for example, you want to increment, okay, a variable. So count equals to count plus 1. So you can use this format, you can use this format, you can use this format or this format. Now, what they're asking you to do, that sometimes in a programming languages, okay, they give you multiple option to do the same thing. Okay, so just to increase the value of this count variable, okay, in C programming language or Java, you have this 4 option. So what they are asking you to do, to make sure your code is simple or your code is readable, just use out one of them. So if you're using the first one, in the whole program, use the first one. Okay, so it will make your program more readable. Second one is first one is simple core features. So instead of doing the task in a much complicated way, try to do it in a simple way. Okay, if you one task can be done using a loop, okay, don't just create another function, then in that function create the loop. Okay, and in some cases, if your program becomes larger, okay, just use multiple functions. Okay, and then we have the orthogonality. Okay, it actually allows you the combination of different primitive constructors. Okay, so let's think about like this, that if you want to print something, we know that the print has command is like print hello world. So print is a token, okay, that actually allows you to print something. Now there might be a possible that we can have multiple combination of printf do this, printf do that. For example, if you search for C programming language, you see that to print a variable, you can actually have multiple syntaxes. Okay, but we always use one, because in our class when you studied, teacher also tried to use a simple orthogonal instructions. So what they're trying to say, that when you have multiple option, whether it's for a control statement, that is if else, loop, okay, or data types and structures, syntax and consideration, okay, always go for the simpler approaches. If you're using if else, okay, try to use well-known control structure. So for example, it might happen between if else and switch, both are control statement, but if else is more popular. People prefer to use if else than go for the if else. Okay, this is a well-known control structure. When you're using the loop, there are different loops: while loop, for loop, do while loop, for each loop. So they are saying use for loop or while loop, because people are more familiar with for or while loop. Okay, so these are simple examples, but that can be extended in other data types as well. Okay, if a task can be done by simple data structures, don't apply stack, tree, or queue. Okay, because those are actually advanced data structure. Don't apply hash table if it's not needed. Okay, then the syntax consideration. Okay, don't use the special words too much. Okay, use a flexible composition. So all these are actually very simple idea to make sure the program is more readable. Okay, so at a small step they don't actually matter that much, but whenever you look at a huge program at the first time is better, because it makes things look easier and more understandable. So that is how our readability